So the third one is centrifugal force on wind force. Centrifugal, center, right? The velocity of each particle inside the blade changes direction as the rotor rotates. There's a velocity, so as the rotor rotates, the velocity is also changing, right? This change of direction is a form of acceleration of particle toward the center or axis as the blade revolves around. I told you before, centrifugal means center, right? So when there is blade rotation, there is also a velocity changing due to the acceleration of the particles toward the center or toward the axis. So this acceleration is caused by what? Centripetal force or centrifugal force. However, for rotating systems such as wind turbine blades and their help, it's common to explain that blade stress due to rotation in terms of frictional centrifugal inertial force, which is equal in magnitude to the centripetal force but in the opposite direction. So it's all about saying this. We have the velocity here. At every plate, at every point, there's different velocity, right? So when there's a change of direction, there's a change of velocity. So we call this centrifugal force due to the centripetal acceleration. We can find it through this formula, and go and check these formulas by yourself. You can find different calculations regarding this. So we have centripetal force and centrifugal force, Newton's third law of motion. So the tensile stress up to its maximum assumed between the plate and top, this one and this one, right? The centrifugal force are always in radial direction, causing tensile stress throughout the whole plate from the root to the tip. This one is the root, we have the tip, so here we have centripetal forces, here we have centrifugal forces. This one is from the plate, right? This one is from the hood. So what's happening here is a tensile stress between these two things. Due to these centripetal forces, there is a tensile stress which can lead us to failure of this wind plate if we don't properly design, and if we don't know this effect, and if we don't try to manage it, it's going to harm our plates. Okay, here we don't have the centrifugal force may vary. We were talking about this thing, the same thing, right? With the size, with the shape and mass density of the plate, as well as the angular speed of the rotor. So centrifugal force increases rapidly as the rotor gains speed. So when there's higher forces in the when there's higher centrifugal force, there's gonna be higher speed. It's obvious, right? So we need to focus on this. The first one is size, the second one is shape, and the third one is mass density of the plate, and as well as angular speed, as well as angular speed of the rotor. We need to know these things, how they are affecting the centrifugal force. The first one was lift, right? In the drag force, we just said this thing, right? So in the lift force also the same. In the centrifugal force, the one thing that we add is this angular speed of the rotor and also the mass density of the plate. So we need to care, or we need to know these things or how they are affecting the centrifugal force. The last one is gravitational force on wind turbine. Gravitational force. The gravitational force acting on any part of the plate may vary with mass density, size, and shape of the plate. It varies with mass density, size, and shape of the plate, right? So the gravitational force are always towards the center of the earth. So when there's a gravitational force, it's always towards the center of the earth. The gravitational force have a variable effect on the plate as the rotor rotates. So maximum tensile compressive stress may occur during radial direction when the plate is vertical, especially when there is a vertical plate or the vertical axis, and when there is a gravitational force towards the earth, there might be maximum tensile or compression stress. So at the same time, when we are designing our wind turbine plates, we need to make sure we consider this effect, which is gravitational force. So while maximum bending happens when the plate is horizontal. So when the plate is horizontal like this, it's gonna be a higher bending stress due to the gravitational force, especially considering the weight of the plate. So the maximum stress caused by the drag forces, the lift force, the centrifugal force, and the gravitational force concentrates a joint between the blade and rope. This one. We have this one and we have this one. So this is the maximum point where there is failurity that could happen. Failurity could happen on our wind turbine energy source. Therefore, this is the point. Proper installation and maintenance of the joints between root of the blades and the hub are critical to the safe and operation of wind turbine. Proper installation and maintenance is crucial.